Hey, good morning, good afternoon, good day, good evening. I don't know what time you're watching the video, but greetings to you guys. So today we're going to be looking at proportional division theorem. I mean, it's literally my first time seeing it written out like that, proportional division theorem, because from the text that I've been reading, it's proportional intercept theorem. Okay, and what does the theorem tell us? Okay, so basically you can see, as I've written there, a line drawn parallel to one side of a triangle, right? So meaning that initially what we have, it's just a triangle, right? Okay, and then we draw a line that is parallel to one side of a triangle. Okay, so we go within the triangle. Okay, let me just draw here quickly so that I can show you guys exactly what I'm talking about. Okay, here's my pencil. So you've got a triangle like this. Hopefully you guys can see. All right. Here's a triangle. Okay, it's just an ordinary triangle, and we're going to say this is A, this is B, this is C. Okay, so if you can successfully draw a line that, you know, joins the two sides, AB and AC, right? You can say I've drawn a line. But there's a difference between just drawing a line and drawing a line that is parallel to the third side. Can you see this is one side, second side, the third side. If you're drawing a line that is parallel to the third side, then we start to have an interesting phenomena. So this we'll just call D, and then this is E. So what the theorem is telling me is that once you've drawn a line that's parallel to the third side, basically now this AB of yours becomes divided proportionally. Okay, it becomes divided proportionally to the other side. In other words, now AD over DB, so AB over DB becomes proportional to AE over EC. Okay, and there's really nothing fancy about the term proportional. It simply means that now there's a relationship between the two. Okay, there's a relationship between the two, and in simple terms, because obviously AD over DB is a ratio. Okay, do you guys agree? AD over DB is a ratio, and AE over EC is also a ratio. So the theorem tells us that the ratios are going to be equal. Okay, for as long as this line is parallel to that line, then the ratio of AD and DB is going to be equal to the ratio of AE and EC. I mean, to me that's pretty straightforward, you know, no complications. Okay, and obviously sometimes you can decide that you want to draw the third line, the parallel line. Sometimes you might have something like this. The triangle doesn't necessarily have to be like that. So you might have this very same triangle, but you draw your parallel line like this, and then we start having the situation over here, this line parallel to that line. Same thing. If this is A and this is B, this is C, and then D, and then E, we're still going to have the same situation. AD, right? AD over DB is going to be, the ratio of AD and DB is going to be equal to AE over EC. Yeah, so notice that we are talking about the ratio here. We're not saying therefore AD is gonna be equal to AE, and DE is gonna be equal to EC. That's not what we're saying. We're just saying if you take the length of this one divided by the length of that one, it's gonna be the same as when you take the length of that one, AE divided by EC. That's all we're saying, that the answer we're getting, like the quotient of the two lengths, right, and that of those two lengths over there, it's going to be equal. Okay, so don't get it twisted. So that's what the theorem means, basically, that a line drawn parallel to one side of a triangle divides the other two sides proportionally. Okay, so that's what we call proportional intercept theorem, or according to classroom mathematics textbook, proportional division theorem. So now let's put the theorem into use. Okay, let's put it into use. So here's a diagram that we're given. Hopefully you guys can see it clearly. You can see that we've got AM, which has got a length of 20 millimeters, and we're also given AB, which has got a length of what? A length of 24 millimeters. Okay, and according to our textbook, the question was determine the length of AL. Okay, determine the length of AL, right? So now we need to apply what we know. Okay, so we're going to say it's fine. We need to write down the ratio now. So because we can see that this line is parallel to that one, then we know that you know, it then divides the two sides proportionally. AM over MC, right? AM over MC, right, must be equal to AL over LB. Okay, so those are the ratios that we have. Okay, so this should be true for as long as we've got these two lines being parallel to each other within that triangle. Okay, now we need to substitute what we know. Okay, so if you check, we know the length of AM, to understand, and this piece of information here, right, AL is to LB is equal to 5:3. So that simply tells us that AL divided by LB gives us 5/3. Okay, so AL divided by LB gives us 5/3. So this doesn't tell us that AL is 5 units and LB is equal to 3 units. It could be that AL is 15 units and LB is 9 units, and 15 over 9 is the same as 5/3. Do you understand? So it's just a ratio. Okay, so now let's use this piece of information to figure out what's going to be the length of our MC. Remember, we've been asked to look for MC. Okay, MC. So now that we know what is AL over LB, let's plug that in, and we already know what is the length of AM. Okay, the length of AM. So let's go right ahead and simplify. So the length of AM is 20 millimeters, and then divided by ML, of which we don't know its length, and that's what we're looking for. And this is going to be 5/3, right? Remember, we found the ratio for AL over LB from that piece of information over there, 5/3. Excellent. So now we're ready to solve for the missing length, which is ML. Okay, so obviously we're just going to cross multiply 5 times ML. I mean, at this point the problem is done, and then ML is equal to 20 times 3 over 5, which is probably like 12. Okay, not too sure about that, but I'm just gonna confirm with my calculator. 60 divided by 5, and that's it, 12 millimeters. So can you see that really, I mean, this is nothing, you know, for someone who's in grade 12, that's nothing. The most important thing is for you to be able to set up this, okay, this, equating the ratios and all that, and identifying the lengths, the sides which are divided proportionally. You know, that's so important. Okay, we found our ml, right? So ml no, oh, that was actually mc. Okay, that was actually mc, sorry about that. MC, so we do have our MC now. MC has got a length of 12 millimeters. Fine. And another question goes on to say, find the length of LB. LB, there's our LB. Okay, that's our LB. We're going to use the very same what we call equation here. It is an equation. So now let's substitute what we know. AM is known, so we're substituting right there. We can try and rewrite this, and let me just try to fix this a little bit. All right, so that you guys can see properly. Just a second, you guys. Right. Okay. So let's rewrite the AM over MC. So not so much space. So AM over MC, this is not going to change for as long as the side ML is parallel to BC or CB. This will remain true, okay, according to our proportional intercept theorem. So AM over MC is equal to AC over LB, right? Okay, and obviously now we've got an additional piece of information that our MC is 12 millimeters. So basically now we've got 20 divided by what? 20 divided by the 12 must be equal to AL. Okay, AL. So do we have our AL? No, we don't have AL. And we asked to find our LB. All right, we asked to find our LB. So how do we go about doing that? LB. And remember, the length of AB is 24. So we do have that piece of information as well. Okay, yeah. So AM over MC, that's 20 over 12. And then let's see AC. No, it's not AC, it's AL. Okay, AL over LB. And we actually don't have any of the lengths of what we call, but I think this is not necessary. Okay, so as long as we know that the whole of AB is actually 24, we can use this ratio to then split it according to 5:3. Okay, so let's leave this one out for now and see what's going to happen. So we want to find LB now. So we know that the ratio of AL and LB is 5:3. Okay, so meaning that now we need to split the 24 that's given. So we can say LB is represented by what? LB takes on the 3 and AL takes on the 5. So LB is basically 3 over 5 plus 8, which is, 5 plus 3, which is 8. And then times the whole length, which is what? Which is 24. 24. Does that make sense? Because LB is 3 over the sum of the 2, which is 8. But AL is 5 over, right, the sum of the 2, which is 8. Okay, so now let's check what answer we're getting. 3 over 8 times 24. That is 9 millimeters. And we might as well just go right ahead and find our our AL, right? AL. Yes. So here we're finding MC. So let's find AL. So AL is equal to what? AL is going to be, remember, it's 5 over there for AL, over 5 plus 3. So it's 5 over 8. And then we multiply with the whole length. Remember what I said? The length AB is actually split into the ratio of 5:3. Okay? It's split. Okay, so AL is going to be some proportion and LB is going to be some proportion as well. And we know that this is the what we're going to use to do the split. So 5 over 8 times 24, which is equal to what? And obviously we could have easily said 24 minus 9 and we get our what? Our 15 millimeters. But this would give you 15 as well. So 5 over 8 times 24, it's giving me 15. Okay, it's giving me 15. So that's how we managed to find our LB, right? Now let's see what else we can find. AC. AC. I mean AC, if you check, AC is simply the sum of AM and MC. So guys, I don't think it's worth my time. So you just add the 2 and then you get your AC. Okay, so I'm sure you guys have noticed that you don't always have to apply the proportionality, theorem, especially when you're given the length of the entire side and it's a ratio. Okay, if you know that this side is split into a ratio of 5:3, and you've got the whole length, you can easily find your AL and LB because you already know how they split, their ratio. So let's move on to the next question, you guys. Let's move on to the next question. So now let's check. This is the diagram that we have, and we've been told that AB is 8 units. So AB, okay, so if AB is 8 units, the whole of this side is 8, right? This is 8, right? So if we happen to have the ratio of AD is to DB, we can easily find the AD and DB, right? Because we already have the entire length of AB, okay, without even having to apply the proportionality intercept theorem. So, and if you check, the two lines are parallel, so meaning that AD, the quotient of AD and DB must be equal to AE and EC, right? Underline, I'm saying the quotient. Now, I'm not saying AD is going to be equal to AE and DB is going to be equal to EC. That's not what I'm saying, the quotient. So meaning that whatever answer that you get when you divide AD and DB, it's going to be equal to the answer you get when you divide AE and EC because of the proportionality intercept theorem. Okay, so now look, we've been asked to find AE, but it's very important for us to start off by reading off the information that's given. So we know that AB is 8, that's fine. AD is 4, okay, AD is 4. I mean, if you know that AD is 4 and the whole of AB is what we call is 8, that already implies that this length here is also 4, right? If this is 4, that should be 4 because the whole length is 4, right? You simply take the 4 here, subtract it from the whole, which is AB. Do you understand? So now we've got AD and our DB. Okay, so let's see. EC is 5 units. Okay, EC is 5 units, 5, and we've been told that ED is AD equal to AD. ED. Here's our ED. It's equal to AD. So this is equal to that. All right, so meaning that this is also 4 units. Okay, so it's very important to read, whatever information that you're given, and then you plug it in, so that it's easier for you to actually be able to see what's given when you are busy solving. Okay, so that's the first thing you do. You read the information, you then highlight, a couple of things, then you get into the actual business, which is solving whatever that you've been asked. So now let's check. We need to find our AE, right? There's AE over there. Okay, what we do know is that immediately when there's a line that's parallel to that line, a line that is drawn parallel to the third side, then our proportionality intercept theorem is going to apply. In other words, our AE, the quotient of AE and EC, is going to be equal to the quotient of AD and DB. Okay, that's what we know. Okay, and after stating this, then you have to say line parallel to one side of triangle. All right, this is a line that's drawn parallel to one side of the triangle. That's the one that's causing this to be true. Okay, line parallel to one side of triangle. So now that we've got this, then we substitute what we know. So remember, we need to find our AE, right? So AE is what we're looking for. Let's see if we've got EC. EC has been given as 5, right? So AE over 5 must be equal to AD. Now we know AD is 4 units, and our DB is also 4 units. Okay, so we're ready to find our AE, right? So AE is simply going to be 4 over 4 times 5, which is just 5. All right, so now what we need to do next is we need to find our AC. Okay, AC, right? Can you guys identify the AC? Okay, AC is like, it's like the whole length over the AC, AC, which is like AE plus EC, right? Remember, EC was already given, and we just found our AE. So AC is simply going to be AE plus EC, right? AC, it's AE plus EC, and we sum the lengths. That's 5 plus 5, which is just 10 units. Okay, and another question says we need to find BC. Okay, BC, right? So let's see where BC is located. There's our BC. Okay, now let's see how we can find our BC. Okay, and here it's quite interesting because we now need to apply what we call the midpoint theorem. Okay, because I hope you guys do remember what the midpoint theorem says. Remember, this is equal to that, but also from what we've been doing, it's been clear that this side is also equal to that side. Also, this side is equal to that side, because both of them are actually 5 units, AE and AC, and that really tells you that the line ED actually bisects both AB and AC. Yeah, now you can go back to your grade 10 Euclidean geometry, notes and all that. You'll find your midpoint theorem. Okay, so a line that joins the midpoint of 2 sides, right, of a triangle. I don't know if I should write it down. I don't know if I should write it down. A line that joins the midpoint of two sides of a triangle and is also parallel to the third side. Third side is equal to a half, is equal to half the third side. Okay, is equal to half the third side. All right. So meaning that now we can safely conclude that ED is half of BC. Okay. So this is not the most accurate description of the midpoint theorem. Okay. So in other words, you should consult with the textbook and check what it says exactly. Okay. But one thing for sure, this is true, that this side is actually a half the third side. Okay. And with this piece of information, obviously that enables you to find your BC. So you're just going to say 4 is equal to 1 over 2 BC. Therefore, you multiply throughout by the 2, BC becomes 8. BC is 8 units. Okay, BC is 8 units. So that is that, you guys, and I hope you enjoyed the lesson. I think we've come to the end of the lesson. So please go and revise midpoint theorem, because I mean, some of these things, what they're gonna do is they're not gonna tell you anything, like, because they know that, okay, you've already done these things in grade 10, so on and so forth. So it's like things that you just need to revise by yourself, right? And my phone is right here with me, so I wanted to read out midpoint theorem for you guys so that you understand what it says. Midpoint theorem. Yeah, so it says, I doubt if you guys are going to be able to see, but I'm going to try and read. The midpoint theorem says that the line segment joining the midpoints of any two sides of a triangle is parallel to the third side and equal to half the length of the side. Okay, equal to half the length of the third side. So in other words, for as long as that line which is joined bisects the two sides, then the assumption is that it's parallel to the third side and also it's equal to half of the third side. All right, so here we already had, you know, the fact that this line is parallel. We just had to conclude that that line is, you know, half the third side. All right, that this line is half the third side, because we already had the information that the DE bisects AB and AC. Bisect simply means that it cuts the sides into two equal halves, right? Yeah. So ladies and gentlemen, that's it for today. Until next time, shout out.